careful when you do, there's more than one way to do some of these. You can do the first one with a log of both sides, but when you bring down the 2x minus 7, you have to distribute that. So in other words, if you bring this down, log or ln, whichever one you want to use, and you bring this down, this stays together. So you're going to have to distribute this. And then add this to this side and divide it by 2 ln 4. So that's absolutely doable there as well. If you can drop them to the same base, it's sometimes a little easier. Okay. 9, just isolate it first and work from there. I must have missed something out of the book over here that I had a B and a C, so as long as you just solved for the equation, that was fine. I pulled it out of the book, I must have missed the other part of it. Everybody good so far? Yeah. Okay, stop me if you have any questions. Okay, when there's one log, this is the second type. When there's one log, you can't delete it, you can't add another log to the other side. You have to flip it to an exponential equation. Whether you use that, log equals exponent, or just come around like this from the bottom to the top equals that. That's another way, it's an easy way to do it. And then solve using whatever it is it takes to solve. Graphically, you can even solve it graphically if you wanted to. Check to see where it intersects. It's a good way to check it. I think the book probably said solve it graphically and algebraically, and I just wanted you to solve it algebraically. Okay? All right? These guys, you could either set it to 8 and solve it algebraically, or you could solve this one graphically. Algebraically was probably what I was looking for. So set them equal to each other, drop it to the same base. Same with the next one. The next one you're going to flip. Isolate this first. 3 to the 5th equals x. 243? Very possible. Okay. The next set, this, whenever you have a fraction, definitely get rid of your fraction. Turn this over. It's much easier. Now do 7 squared and then raise that to the -1. Much easier to get the fraction out of there. The negative reciprocal, the -1 just takes the reciprocal. So reverse that. This one's nice too because this is the same as 3x, 4x. And you can kind of just see the cube right there. You good? Yeah. Okay. And the harder ones are probably the ones that are giving you grief. Okay, again, here's the second type of equation. There's log on one side. So flip this to an exponential equation. These guys, you're going to use your power rule first to bring down your x squared, and then ln e cancels out. And you just got x squared. Go ahead.
I just didn't know.
I didn't say, yeah, I just didn't say simplify. I must have just grouped those all together. Solve. I pulled them out of the book because I know you don't like the book, but I must have missed that directions to that. So you just had to simplify those two. That one also. When you raise e to the ln, that also cancels out. So you bring that down.
I was very confused
about what to do with those. I just missed the directions in the book part. I don't know why they were stuck right in the middle. They were stuck right in the middle of everything else, so I just assumed.
That's why I just set it equal to 0, but.
I see.
But that's not what.
Yeah, I have to look. It's right smack in the middle of the whole thing, so I don't know why the directions changed for that one. I'll have to look. I pulled them out of the book, and I thought I had good directions on there, but I didn't. Now this guy, There's no way to make a base of 8 or a base of 2 to get 360. 4 isn't going to help us. So take the ln or take the log of both sides. You can absolutely take the log of both sides and bring down the 3x. Be careful when you put this in your calculator. If you don't get the right answer but you did the right equation, you probably didn't put the parentheses in the denominator. If you use your fraction key, it kind of takes care of that. But otherwise, you need those parentheses. Otherwise, it's going to divide by 3, and then it's going to multiply by ln 8. So just in case you have the setup but you're not getting the answer, it's probably the parentheses. And number 5, take the ln or the log. I kind of interchange so that you see you can interchange them. Whenever you have an e, you have to use the ln, but you can use it all the time. It's kind of the universal. So as I said, most colleges in college courses, they just use ln. Bring the exponent down. When you bring this exponent down, it has a fraction. Get rid of it. If you multiply by a negative 2, this is going to give you a t. And then just multiply this guy. This is one term by negative 2. Now you divide by log 5, and you'll be fine. Multiply by its reciprocal. Questions? We're good so far? Okay. These guys usually are pretty nice because if you don't spot instantly that they drop to the same base, you're going to put logs on both sides. That was your property, that you're able to put logs on both sides and take them away when they're one term, one term. Okay, you have to isolate that first. Isolate that whole thing. That exponent, 3 minus x, only belongs to the 2. So divide by 5 if you like, or if you take the product, you can take the ln of both sides and then use your product rule. Either way. If you take the ln of both sides right here, use your product rule. ln 5 plus, bring this down, and then continue from there. But what you don't want to do is take this and reduce this to a decimal. You want to leave that as exact as you can be. The last step, same as algebra 2, the last step is where you do any rounding. Not in between. Because you guys did these in algebra 2 as well.
I have a question.
Question?
Why did you multiply 3 minus x with the ln 2?
Say that again.
Why'd you multiply?
Well, I brought down the exponent.
Oh, you just brought it down.
Uh-huh. And then I just divided first by ln 2, and then I added the 3, subtract the opposite of the x. And there's a number of ways to do this. You could distribute it and do it the other way. This is probably the most correct way up here, to do it this way. Then distribute it, subtract, divide. It's just a little bit longer that way. If you just keep track of all your parts, you should be fine. And this is an equation. Take your answer and check it. First, go plug it back in. Now, because we rounded, it'll be approximate. It won't be exact. If you leave in the exact parts of it, then you'll get the exact answer. $67, same thing. Bring down your exponent, but it belonged to that whole thing. So divide everything by everything but the t. Again, if you're going to use your calculator, watch that denominator. That's why your fraction key is kind of nice. You don't have to worry about any parentheses. But if not, put that denominator in parentheses. Are we okay on these two? I know the next one is going to be a little troubling.
Where I'm confused as to where number 67, where the log should go.
Here.
Yeah.
And then I just took a shortcut. I divided everything by this. I just didn't write it out again. Divide log 2 by this. I usually just put a line across the bottom.
Yeah, I just do it to make sure.
Okay, so 71. Let's take a look at 71.
Oh, this
What
is
if I,
confusing.
okay, but what if I gave you this? How would you factor this quadratic?
Oh, you're asking me?
Anybody? How'd you get the x? How did you know it was x? You took this because these have to add up to this, right?
Yeah.
So essentially what you're saying is take this divided in half. When you do this, how do you know that this is x squared? Because when you add them together, they add back to 4, right? So you took half of it. You took half of this to get x squared. It's just that you do this without thinking. So you say, yeah, x is true because 2 plus 2 is 4. Same process. How do I separate this out? Isn't x plus x 2x? Shouldn't this give it away right here? Same as this gives it away right here? True. And when I look at this, I say, well, I know I need to add them to get to this. Well, and then same thing here. I know I need to add them to get to that. Isn't that where my first term comes from? Right? If I did x to the 8, what would you separate this into?
I thought.
Isn't this middle term then x to the 4?
I just wasn't sure because I didn't know if having it be e would be a problem.
No, not a problem at all. It's a variable.
But
It's different. It was just something different in there. A good thinking problem. I need to apply my logs to this. I need to apply my quadratic, my factoring to this. And you normally don't see 2x in your variable. You see x, just 2. You see x squared. You see x to the 4th. You see x to the 16th, whatever. You see something even like that. But it's the same process as when you do x squared, x to the 4th. You just do it in your head so much that you don't ever think through it. So separate these out just like you would that one. Set them both equal to 0 and solve. Each one solve. Now, when you get that to here, go back and look at it. Go back and see which one will fit in, which one I will have to reject. And it's an equation. Check them. E, you're going to raise to the 2 times whatever you get, minus 4, e to whatever you get, minus 5.
But if you take the log of a negative number and calculate it, I have to look and calculate it.
What do you get for an answer?
Well, if I do log of negative 1, it's like 1.36.
Log of negative 1, it shouldn't because your logs go here. Your domain is 0 to infinity.
Yeah, I know.
Is it giving you,
I have a number.
are you an unreal number, an imaginary thing?
Maybe.
Is it giving you an I at the end or something?
Oh, yeah, it is.
Something has an I at the end. If you keep your mode into the second one, the A plus BI, it'll do your square roots of a negative number as well. It'll take the I out, but we only use the real numbers for ours. Okay, and we know we can't take the log of a negative number because we know our domain goes from 0 to infinity. We can't use a 0. Good on that one? Okay. It has the same process, it just looks a little strange. Okay, again, we have one log, so we're going to have to flip this. So my log doesn't have a base. What's the base on the ln? E. E to the 2.1 equals 4x. Number 10. Now number 10 has a base 10 in it. Most of the time, you're going to see it without the base 10 in here. It It's understood to be base 10. So it's going to have the same problem as your LN. Where's my base? You're going to have to add the base in here. They put base 10 in there, so that kind of made it nice for you to see. 10 squared equals, and you're good to go. But don't forget, if the base is not there, it's a base 10. These guys, we had logs all over the place, so we said if we can get down to log equals log, ln equals ln, then we can cancel them out. So we knew when we were subtracting our exponents that we were dividing our like bases, so we turn this into the quotient rule. Once you get to this point, this is one term, this is one term, cancel them out. And then solve. Again, make sure you check. Just
Neither
because...
of them work. Neither of them work, right?
Neither work?
Yeah.
Let me see if I can get no solution underneath it. Let's pull this down a little bit further. I think my page got cut off again. Now, but don't discount it because it's negative. In a case like this guy, the negatives will work. In here, yeah, they will not work. But sometimes it works out that your argument allows them to work. So just because they're negative, don't discount them. Make sure you put them in. If you have none of these that work, then we have no solution.
It has to fit all of them?
It has to work in all of them because you can't take the log at any point here of a negative or a 0. So as soon as you plug something in here, less than 1, less than a little bit more than 1, you're going to get a 0 in here. So that you can't do.
So you can't have 1?
You can't have 1. Because that would give me a log of 0. Try it. When you go to plug it in, it should say out of your domain or non-real or something. This gives you some kind of error. Domain error. That's why it's nice at first to go through your domain first. Again, I have a whole lot of ln's all over the place. Get them down to ln equals ln. This one, yep, I have to factor it, but we can't factor this, so we have to use the quadratic equation. Now the negative root of this is going to be outside your domain, because as soon as you say negative minus 2, you're done. So we're going to reject your negative and just keep your positive. We kind of mixed a little extra things in here.
What?
We
Oh, I
mixed
thought you were asking me a question.
No, we mixed some extra things. We gave you one where you had to factor something that had a different exponent, something that had to use the quadratic. You can complete the square if you like instead. And this one, number 121, that's probably a little confusing as well.
I got to e to the first equals x squared minus 2x. That's it. That's as far as I got.
So you got e to the first, you got this far,
Yeah. And then
okay?
I was severely confused.
Right, so when you get here, shouldn't you be able to factor a trinomial?
Well, yeah, but I didn't know you could do e's with x's.
Right.
That's why I was confused.
Right. But you can.
Oh, that's a good thing.
Yeah, that's fun, isn't it? It makes the life a lot more interesting.
If it was like negative 2e, you couldn't do it, right?
Negative 2e? Yeah, well then negative 2, then 2e is your c. You can, because that's c. Negative 2e would be c.
No, I mean, like negative 2e minus e, x squared minus 2e minus c. No, yeah. I don't know.
I don't know where, I'm not following you then. Where would you have your e? 2e here?
No.
No.
And the next one.
Here.
Books are hard. Oh wait, no, it wouldn't matter.
Okay. Just something to work through and try.
Wait,
Challenge yourself.
why are there 2 radicals in the numerator? Yeah.
I just took this and separated it out. I factored out a 4.
Oh, you didn't, okay.
I factored out the 4, then I separated them into 4 times 1 plus e, so I could take the 2 out. This is not on the same line, I just factored this. It's far easier, otherwise you're stuck with this until the very end, and you can wait till the very end and use it that way as well.
That's what I was gonna
That's
do.
fine. You could do it either way. This one probably no. But it's a good challenge. You should all rise to this challenge. Really, there's nothing different. I mean, if you didn't do this part, that I get. If you just bring this all the way down, couldn't you put this in your calculator at this point? 2 plus this,
Yes.
then 2 minus this? You're going to give me an answer anyway. So at this point, you can get all the way down to here. You're fine. You're fine, right? It's going to give you the same answer. I just saw that it'll come out, so I factored it out.
Oh, boy. Oh, never mind. My mathematical error.
Because watch what happens. I'm sure you all reached this point. Well, you can't factor this. You can't factor this. If you put e to the 10th in your c, that's fine, if you wanted to do it that way. But this is not a quadratic, so you had no way to take an x out of this. So there is no way to factor this. So if you put it in your calculator and did an intersect, you could find where your 0 was. I definitely would not give you one of these. I just want you to think about it. Think of other ways. How do I approach this? Yeah, this doesn't fit my pattern. I can't take an e, I can't take an x out of here. So there's no way that I can factor this. I can't use my quadratic formula because it's not a quadratic. How else do I know how to solve? Algebraically, I could try graphically. Because this is equal to 0, guys.
If I had just put, like, if I wrote on my paper x cubed plus 4x minus e to the 10th, would that be okay?
Well, you still, and that's what that is, but you still have to give me a solve for x, right?
Yeah, no. I mean, like, instead of the...
Yeah, I just did this out so you would see, regardless if you had e to the 10th or you had that, there was no way to
But
for you to factor.
I can just plug that into my
Yeah,
calculator.
absolutely, with e to the 10th. Yeah, absolutely. Is that you have a lot of, like, things to write in there, which is why I say if we can take a little shortcut, let's take a shortcut. Because when you write out your logs, then you have to separate that with a product. Then you have to subtract from that side. Then you have to make another row of it. You have a lot to rewrite. If you can do it this way with a good understanding that don't simplify these to, decimals, keep them as fractions, or if it terminates, you can keep it as a decimal. It still works the same. It still is a little bit lengthy. They're not all that bad. Okay, so let's try another one. We have this on the same packet, number 4. So if you have your packet available, we said determine when an investment doubles. So we had a 2 to 1, and we were compounding continuously. So your formula looked like this. Curve, right? So is this what you had for number 4 on that same packet? And we solved this graphically. We said, okay, when am I doubling? Again, I'm looking for time. So now, we know how to break down that log, that exponent, using a log. We're going to take the ln of both sides. This one's a lot better looking. So we use our power rule. We bring this down. What happens to ln e? It gets crossed out. That's one of our properties. So therefore, solve for t and divide. That's probably even easier than doing an exponent on the graph, right? And what'd you get for t? 11.552 years. Thank you. Which will be the same thing that we did, and we solved it graphically. With the e, you have to use the ln. with this part up here, compounding your money, there's no E. You can use log or ln.
You use subtract when you do the plus R over N.
Oh wait, let me see where you are. Yep, look this one up. This was in your first one. You are decreasing, so this is your 1 minus your rate. It all falls into this guy. So that's going to be over here. So we wanted to know when it would be 50,000. If we started with 123,000
Wait, I can't find this stuff.
and we decreased, we can just make this.
We can just make it.
Yeah, we'll just make it. But you can, when you're home, look back to your work to see and make sure that you still did it the right way. Or just look it up. It's easier than having to rewrite the equations.
The original equation is A equals P.
That's compounding. These follow this formula, ABX. This is where my rate is. This is my initial. This is my rate. So if I'm doubling, there's a 2. If I'm halving, there's a half. Remember those? If I'm decreasing a population, it's a 1 minus. If I'm increasing, it's a 1 plus.
Yeah.
Okay. Now, same thing here. Technically, we should take the log of both sides and we should use a product rule on the right-hand side. But if you want to, because your t only belongs to this argument, just divide this out and get rid of what you can. Reduce this down. It's not going to terminate, so if you kind of reduce it to, it's probably 50 over 123. Now, what should I do to bring that exponent down?
I'm gonna do
Hmm?
ln.
Take the ln or log of both sides. You can take the log of both sides. Whichever one you decide to use. You could absolutely do this piece in your calculator too, if you'd like to. And then move the t down. And divide by that mess. And divide by this thing right here. And you'll find your t. Okay, so this is how we solve these algebraically. So I gave you just like maybe 4 or 5 more. Match them up to your packets and then you don't have to recreate your equations.